Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science 2023 Physics Paper 2 Foundation Tier. Question number 5 is on the topic of forces. Figure 13 shows an engineer climbing up a ladder. The distance between each rung on the ladder is 30 centimeters. So what they're saying is between each rung means basically the bit where he's stepping on. So the distance between from there to there is 30 centimeters. What is 30 centimeters in meters? So they are asking you to convert 30 centimeters to meters. How would you do that? If you remember, there is 100 centimeters in 1 meter. So if you divide 30 by 100, you'll get 0.30. So the answer is 0.30 meters. The engineer has a weight of 710 Newton. Now weight is a type of force. That's why it's measured in newtons. So right, force. Calculate the work done when climbing up one rung of the ladder. Use your answer to question 5.1. Again, the answer that we chose was 0.3. You could use, if you had chose 30 meters because you made a mistake, you'll have to use, if you use that answer, you'll still get the 2 marks. So the answer that we chose, which is correct, is 0.3 meters. So the force that they have given is 710 Newton multiplied by 0.30. So again, let's bring up the calculator. 710 multiplied by 0.30. That's 213 newtons. 213 Newton meter. The engineer climbs the ladder carrying some equipment. Give the reason why carrying equipment increases the work done by the engineer when climbing the ladder. Now, if you're carrying equipment, now if you're on your own, on its own, the engineer has a weight of 710 newtons. So if he's carrying equipment, then he's carrying extra weight. So which means the force is going to increase, although the distance remains the same. So the total force or weight is greater or bigger, any of those words is fine. The engineer is stationary at the top of the ladder. Which energy stores of the engineer increases due to the engineer climbing the ladder? So when the engineer is climbing the ladder, what type of energy store is going to increase? Chemical energy? Well, the chemical energy comes from inside the body. He's actually using energy. So that's actually going to go down. Elastic potential energy, he's not stretching anything, so there's no elastic potential energy here. Gravitational potential energy, which depends on the mass of the person, the gravitational field strength, and then the height. This is the important bit. The height is increasing as he goes up, so the gravitational potential energy increases. Now they want you to tick 2 boxes. What happens to the kinetic energy? Well, as he is climbing up, the kinetic energy, right? He's stationary, so he's actually stationary, so he's not moving. So kinetic energy is moving energy. Thermal energy, yes, the thermal energy of the person is actually going to increase because his body is going to get warm. And try climbing up about 100 or 200 stairs continuously, and you'll feel that your body is actually getting warmer. So your gravitational potential energy is increasing and the thermal energy also is increasing. Use the physics equation sheet to answer questions 5.5 and 5.6. Write down the equation that links gravitational field strength, which is G, mass, which is M, and the weight, which is W. So if you look in the equation sheet, you can either write the word equation or the symbol equation. Let me start by writing the symbol equation. When you write the symbol equation, you need to make sure that you're using the symbols correctly the way they have given. This is a capital W equals M, lowercase m, and G is also lowercase. Not if you put capital M or capital G, then you're not going to get the mark. Or you could actually write down the word equation, which is weight equals gravitational field strength multiplied by the mass. Sorry, I have written it the other way around. Now, whichever way, it doesn't really matter. The engineer has a weight of 710 Newton. They have given the weight. The gravitational field strength is 9.8. Calculate the mass. So for 4 marks, they're asking you to calculate the mass. So if I use the same equation, W equals mg. So let me substitute it. The weight is 710 equals the mass is what I'm trying to find, multiplied by 9.8. Now I need to rearrange the equation so I can get the value for m. So I would divide both sides by 9.8 to get rid of the 9.8 on this side. That means 710 divided by 9.8 gives me the mass value. So again, let's bring up the calculator. (710) divided by 9.8. Oops. 0.8. That gives me 72.4489. So 45 rounded up. Now getting this answer would give you 3 marks. To get the 4th mark, you need to write the answer in 2 significant figures. Right? They have asked you to write the answer in 2 significant figures, and they have reminded you over here at the bottom that your answer needs to be in 2 significant figures. 2 significant figures, because it's less than 72.5, it'll just simply be 72. That brings us to the end of question number 5. Now question number 6, which is on waves and electromagnetic waves in the foundation paper, is exactly the same as question number 1 in the higher paper from 2023. So if you want to know how to answer question number 6 and question number 7, which is forces on the required practical, question 6 and 7 is actually question 1 and 2 in the higher paper. So watch the videos for question 1 and question 2 from the higher paper to find out how to answer question 6 and 7. Thanks for watching. If you found this videos useful, hit the like button, make a comment if you think you'd like me to make any improvements or you want any other papers. Thanks for watching, and I will see you in the next video.